All right, let's start talking about A5. There's no way we're going to finish A5 today, I don't believe, but we'll at least get started on it. But like I said earlier, this will be our last lesson. 8.5 will. I might take one other day to finish this up, but this will be the last section that we do. All right, so let's talk about a theorem. Let me draw a couple things. I'm going to draw a chord. And then what I'm going to do is draw a tangent. Well, this is technically a chord, but it could keep going forever and ever. What if it kept on going? What do I call this thing if this kept on going forever and ever? It was a line. It's a secant. Good, I heard secant. This is a secant, okay? Goes through the circle, right? Now, if that secant hits the circle, let me try to draw this best I can. Yeah, it's not bad right there. Okay, everybody see this? So this hits at, where do you think it hits, that secant? Yeah, right there, that point. That arrow didn't really point to it. Let's try this again. It's still off, but you get the idea, right? There's that point right there. That's the point of tangency. So it creates an angle, doesn't it? This is very similar to what we've done before, that inscribed angle. Remember that? Come on, there it is. Remember that inscribed angle? So this isn't really an inscribed angle because this line right here doesn't go inside the circle, does it? All right, it just touches the circle. So it doesn't go inside the circle, but it's very, very similar to the inscribed angle. I want to show you the arc that it cuts off. So let's look at this angle right there. We don't give it a name. Let me look. Yeah, they don't really give it a special name. They just say it's the angle between the secant and the tangent. All right, it'd be nice if they gave it a special name. They don't, but that's what it is. It's the angle that's formed between the secant and the tangent. Everybody understand that? All right, so that's my secant, that's my tangent, that's the angle that's formed. Well, you got another angle here too, and it still works with that, but let's just talk about this angle right here. So it's kind of close to, oh man, almost had it. That's close enough. Man, I had a good start, didn't I? All right, so this arc right here, it's very, very similar to an inscribed angle. So what do you think might be true about this pink arc right there? It's half? Something's half, but not the arc. That's it. The arc is double the angle. Or the theorem actually says the angle is what? Half of the arc. Okay, that's technically what the theorem says, but it works both ways, doesn't it? If the angle is half of the arc, that means what? The arc is double the angle. Everybody with me? So if I told you that that arc right there was 154 degrees, that pink arc, what would this angle be? Is it 77? Yeah, it is actually. It's 77 degrees. So it would just be half of it. Make sense? Again, very similar. It's not technically an inscribed angle, is it? All right, because this one right here, this tangent, doesn't go inside the circle. Okay, but the rules are the same. Okay? And obviously, what would this angle be right here? Let's do a different color. Come on. Because what if I asked you to find the green arc? Okay, what is that?
It's about
250 or 166? Okay. So that would mean that this is 166, which means this would be what? No, yeah. What did I do?
It'd be 206.
Hold up, let me think. Yeah, I was going to say, it's 206.
I just listened to I don't want to hear that ever again.
All right, hush, 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 hush. Everybody look up here. Let's worry about this. Everybody look here. Shh. Listen. Oh, okay, I gotcha. Yeah, so this is what? 206, is that what you said? All right, so what's this angle right here? Now, look where it's from. It's not like from the curve. It's from the angle itself, right? It goes to there. And what would that be? It'd be what? 103. Does that work out? Look at that 77 and that 103. What do they form? Right, they're supplementary because they're the two angles of that tangent. Everybody see that? So it all works out nice and easy. Everybody got it? So depending on what they tell you, you could always find, right? So if they told you it's 154, you could do the green arc first, or you could find that angle, which is half of it. Then you could find the green arc, if you want, is 360 minus 154, which is 206. Then how do you find the angle? It's half of that. Everybody got it? Okay. There's an example, but the example is, let's do this. The example is pretty much just like what we did. So that'd be a waste of time just to do that example. Because it's a tangent line. Okay? Because remember, the angle between the secant and the tangent, that angle is half of the arc that it cuts off. It cuts off that arc right there. Same thing with this. This angle from the secant to the tangent is half of the arc that it cuts off. That means the arc is twice as big as the angle. Everybody got that theorem down now? Yeah, it's very similar to what we just did yesterday. All right, let's do another one. This time, we have two secants, and they actually intersect each other inside the circle. Now, secants keep going forever. I could put the arrows. I'm just too lazy, so I'm not going to do that. So what should I do here? Let's call this angle 1, and let's call this angle 2. Let's put some letters. So let's go, because we got to talk about the arcs anyway, so we need some letters. So D and C right there. And then the center, we're not really going to use the center on this one, but we'll put it there anyway. All right. Now look what we have. We got two what? Two, well, secants. We have two secants. Okay, that's what we started with. Those two lines right there, right? They go through the circle, hit at 2 points, and they intersect each other. They intersect each other right there. Now, this is something that just by looking at it, you might guess, but I don't think there's any way you're going to guess. It almost looks like this arc and this arc are the same. Almost, but they're not, okay? Like 8B and DC. They are not the same. Everybody understand that? Now, they could be. There could be certain situations where they are the same, but they're not always going to be the same. But here's what we know about it. So angle 1 is equal to half of the sum of the two arcs that it cuts off. So what arc does angle 1 cut off? Arc what? AB. What arc does angle 2 cut off? Arc DC. That's basically what your theorem says. I just didn't write all the words. I think that's a little easier to understand just by looking at the picture, don't you? Instead of writing a whole bunch of words there. I think it is. So that's what this thing says. If I have two secants that intersect inside the circle, right, then the angle that's formed, this angle 1 that's formed, is equal to half the sum of the two arcs that it cuts off.
Wait, I'm confused. Is it half like putting the other half?
Not necessarily, okay? Because I could have changed this like that. Look at that. Does that arc and that arc look the same? Obviously not. But if I took this, let's say this arc is, I don't know, I'm just making these numbers up. I don't know if it's to scale, but let's just say, all right? So let's say that that's 20, and I don't know, let's say it's 100, okay? Everybody with me? It's like a little mini example. So if that arc is 20 and that arc's 100, what is this angle right there going to be? Okay, how'd you get that? You went 100 plus 20, and then what'd you do? Divided it by what? 2. So 120 divided by 2 is 60 degrees. So that arc is 60. What's this arc going to be right here? Or not arc, sorry, angle. What's that angle going to be? It's going to be 60. Why are they both 60? 60 and 60. Because they're what to each other? Vertical angles. They're vertical angles, okay? And vertical angles are always equal. So once you find one, the other one's going to be the same thing. We didn't really talk about it up here. We did. Oh, I moved the stuff around. I had that angle 1 and 2 here. But anyway, Yeah, there you go. That's not too bad, is it? So let's review. If you have a secant and a tangent, then the arc that cuts off is just half of that angle. Everybody got it? Secant and a tangent. When you have two secants, they intersect each other inside the circle, then what you do is you take the two arcs that they cut off, right? Because there's two different arcs that they cut off, correct? This one and this one. You add them up and do what? Divide by 2. It's kind of like finding the average of the two, isn't it? It's kind of like the average of these two arcs. That's what that inside angle is going to be, right? When I take two things, if I add them up, divide them by 2, finding the average of it. So if you want to think of it that way, you could think of it that way. Again, they give you an example. You look in the book at the example. I pretty much showed you right there. We kind of did our own little example. All right, let's do another one. Let's do two secants. Now, those two secants intersected where? Where'd they intersect? Come on, we said it a couple times. Two secants intersect where?
In the circle.
In the circle, that's right. Inside the circle. They intersect right there. Inside the circle. When they intersect inside the circle, you take the two arcs, and what do you do with the two arcs? Add them up, divide by 2. This one's a little different. This is two secants. Guess what? They're going to intersect outside the circle. Okay? And they form an angle. See the angle right here that they form when they intersect outside the circle? They also cut off two arcs. Let's draw those. Cuts off that arc, and let's do it a different color. It cuts off this arc. You see that? Those two secants, right? It's going through here. It hits here and here. This secant goes this way. It hits right here and here. It cuts off those two arcs. Now, here's the difference. You don't add them together and divide by 2. You subtract them. That's right. So let's put some letters in here. We'll say that point where they intersect is A. This is B. That's D. This is C up here. And this is E right there. All right, so let's write it down. So angle A, we'll call this angle A. Is that all right? So angle A is equal to the difference of the two arcs, half the difference of the two arcs. All right, so half the difference of the two arcs. Now, does it matter what order you subtract?
Yes.
It always matters what order you subtract. Addition, does it matter what order you'd add? No. All right, because if I go 2 plus 3, that's the same thing as 3 plus 2, correct? What about 3 minus 2? Is that the same as 2 minus 3? No, they're different, okay? So it absolutely matters which one. So if I want to keep this a whole number, or a positive number, which one am I going to do first? The big one, that's right. Take the big one, so I'll use CE. And then I'm going to subtract the smaller one from it, which is arc BD. Everybody got that? So this, again, are two secants, but it's a little different than what we did before. Why? Because they intersect where? Outside the circle. So when two secants, right here, intersect inside the circle, you add the two arcs and take half of it. When they intersect outside the circle, you do what? Subtract the two arcs and take half of it. You with me? I don't have to put numbers in there. You can do that yourself, right? If I put numbers in there, all right. Wow, we're getting close to the end of this. I thought we'd only get a little bit through. It is pretty easy. No, not really. Measure an angle formed by... Oh, okay, let's do this. I don't know why I put that theorem there, because that's the same theorem that we did earlier. Yeah, secant, tangent. Oh, I see what it's doing. They don't intersect at the point of tangency. It's been a while. Let's do another one. We got 2 more to do. We got 5 minutes. Can we get 2 done in 5 minutes?
Hopefully.
Yeah, hopefully. So here's a secant. Now watch. Here's a tangent, but it doesn't. The tangent and the secant don't intersect each other at the point of tangency. Remember the first one we did? They intersected at the point of tangency. But here's a tangent. But where do they intersect? Not at the point of tangency, but where? Yeah, but where is it to the circle? Outside, right? Right? We've talked about inside, outside the circle, right? So they intersect outside the circle. Now, watch very carefully. Here's the point of tangency right there. I'll make it kind of fat. All right? And here's an angle. And let's put some letters in here. They use this as F. This right here is E, B, and A. And the point out here is G. All right, here we go. So we still have a secant and a tangent, but they don't intersect at the point of tangency. They intersect outside the circle. Yes? Okay. So there's something that we know about this right here, and it's very similar to what we just did. It's like two secants that intersect outside the circle. So what do you think? We'll call it angle F. Or actually, they call it 1. They put a 1 there. So let's call it angle 1. It's going to be the same kind of thing. It's going to be half the difference of the two arcs. But the two arcs, they're not separate, are they? They kind of touch each other. So look, this, come on hand, be steady. There we go. And then this right here. Everybody see that?
What's the point of G?
I don't know. I almost didn't put it on there because there's really not. It just really doesn't help us that much. But look at angle 1. It's equal to what? Half the difference of the two arcs. Just like when it was two secants intersecting outside the circle, it's the same math, the same equation. But it looks a little different though. Okay, they're not two secants. It's a tangent and a secant, but they do intersect outside the circle. Okay, so how am I going to write this? Half of what? BA, arc BA, minus arc what? EA, or AE, doesn't make any difference. There you go. We got one more to do, and I got like 2 to 3 minutes to do it. Because this is the point, this is where it splits it, right? The tangent hits the circle right here at point A, and so it makes this arc, and it makes this arc right here. What did I just do? I made it look weird. There we go. Okay. I don't know what I just did. All right. Everybody with me on that one? We got one more. So this one, we've had two secants, right? We've had a secant and a tangent. What do you think we're going to have now? Two.
Tangent and a tangent.
Right, two tangents, right? So let's do that. So let's say we had a point. Watch, we had a point out here. And I want to take from this point tangent to this circle. We've done this before. Then I'm going to go from this point tangent to this circle. Well, the same circle. So look, I got a point of tangency here, I got a point of tangency here. Now, the nice thing about the last three that we've done is the same exact equation, all right? The same exact thing. So let me put some letters. If the bell rings, just hang on. It'll only take a minute to do this.
Logan Hill, Ariel Nyasi, Natalia Moore, Gabrielle Florio, Kristen Bynum.
All right, here we go. You probably could write down what this formula is, I would guess. Could you?
Braden Coleman,
So angle 1,
Lewis Perez,
I tell you what, let's do the picture thing or the...
and Trent Montgomery to the front office.
All right, look, now this is a little bit, listen, everybody stay here. This is a little bit different, but kind of the same. Now let's go pink. We've been going pink. Let's go pink. Hold on. That wasn't half bad right there. All right, let's figure out what we're going to do. Look what it does. It breaks it basically in two parts, doesn't it? All right, so those two parts make up the whole entire circle. Yes? All right, so what can we do? 1 equals 1/2. What do you think? Arc. What's the big arc?
CA.
Yeah, why do I have to go CBA? Why can't I just say CA? Because it's a major arc. It's more than 180, right? So I got to use the 3 letters. So it's CBA minus arc CA. And we pretty much did, except for one big example at the end, we pretty much did that. But no homework on 8.5. Do your homework from 8.4b. So your homework is 8.4b. What were the numbers? 17 to 29.
What was the one for 8.8?
8-4A was 1 to 13.
Okay.
So 8-4A was 1 to 13. So both of these, listen, shh. Both of these are due tomorrow. Okay, tomorrow we'll probably have at least 5-10 minutes, right, before they do that parade thing. All right, so make sure that you have it done for tomorrow.